Hello, Maurits here. In this video I will introduce what is called the normal distribution. And why it's called normal is because so many things follow this distribution, and it's a distribution of continuous variables compared to the binomial distribution, that is a distribution of discrete values. And a lot of things will follow this, as I said, and you might recognize this as if I draw a curve that looks something like this, a bell-shaped curve. And it could, for example, be the length of people or the foot size or result from a test or something. Quite often they are distributed like this. So in the middle here we have the mean, the expected value, and I'll write that with a mu. And then a bit outside here, actually, if you look at the curve, exactly where it goes from turning concave down to concave up, so this inflection point, we are one standard deviation away. So this is +1 standard deviation, and over here we are -1 standard deviation. And to specify the shape of this, or what kind of normal distribution we have, so we have a random variable x. We write that that is of the type normal distribution, and we specify that by giving the value of mu and this thing that we have to remember, that is called the variance. And variance, that we write like this sigma squared, is the standard deviation that we write as the sigma squared. So the variance is simply just the standard deviation but squared. So let us look at an example to make some sense of this. Say someone is producing some bread. We can, if they do in any normal way, we can guess that the weight of the breads, the mass of the bread, will be spread according to this kind of normal distribution. And this curve, by the way, I will explain more in detail what it stands for. Okay, so say we have that the average is 500 grams and that the standard deviation is 10 grams. So we have this bread with an average of 500 grams and a standard deviation of 10 grams. That will also mean that the variance would be 10 squared or 100. So we would specify that this, say x is the random variable corresponding to the mass of the bread, is normally distributed with an average of 500 and a variance of 100. So what kind of calculations could we do in this, and what does the curve mean here? Basically the curve will give you something called the probability density. And basically what we have is that the area under the curve will correspond to the probability. So for example, we have here is 500 grams and 1 standard deviation away. We said that was at the inflection. We are at 510 grams, since that is the average plus 1 standard deviation. And over here we have 490 grams. That will be -1 standard deviation. And I said the area under the curve correspond to the probability. So if we, for example, ask ourselves, what is the probability that the bread happened to be between 500 and 510 grams, that would be to find this area here. And how can we do that on the calculator? So we'll go in under the menu, stat, and distribution. And now we go to the normal distribution. This first one we basically never use. This is the one we should use, the cumulative, and it will calculate from one value to another. So I choose that one. And we say here that, okay, we have some bread, lower value of 500 grams. That is the lower value we look at. an upper value of 510 grams, and standard deviation of 10 grams, and an average of 500 grams. So we enter these values and we calculate this, and we find that the probability for the bread with this distribution to be between 500 and 510 grams would be 34.1%. We have, all in all, always that if you are between plus and minus 1 standard deviation, it will be twice this value. That is always true for any normal distribution. If you are between plus and minus 1 standard deviation, you are at the twice of this value. So we can go in here and say, okay, from the lower end, 1 standard deviation down, 490 grams to 510 grams, and we find this area from minus 1 standard deviation to plus 1 standard deviation to be about 68.3%. It's nothing you need to remember by heart, but it's fairly good to recognize that. So this curve is symmetric. So if we will calculate what is the probability to be above 500 grams, we'll find that that should be 50%. And below 500 grams, the same thing. So how can we do this calculation? So I say, okay, now the lower value is 500 grams. The upper value, I write something very, very big, say 9x99. It's just saying that we are going very, very far away on the curve. You would get the same answer if you write 10,000 there or anything like that. We keep the standard deviation and the average, and we can see that it finds the probability to be 50%. The chance that you are above 500 grams is 50%. The chance that you are below is 50%. Because the total area under this curve should be 1 or 100%. Because the total probability is always 100%, right? So say we have a question here. You buy some bread. What is the chance that your bread happen to be more than, say, 520 grams? So we want to calculate this. What is the probability that our random variable x is larger than 520 grams? So we just go into the calculator and say that our lower end is 520 grams. Our upper value, say we pick something very, very big. We calculate here and we can see that that will give us about 2.28%. That is how we could calculate probabilities quite easy. If the distribution is a normal distribution, and in a question that will always be said if it's so. But we can remember here that a normal distribution is the distribution where you basically have this bell shape, you have a middle value, it's symmetric, and you have 1 standard deviation away where the curve curves out like this. Same thing that direction, so that will be the point of inflection, and that we specify it by giving the average or expected value, and the variance, that simply is the standard deviation squared. In most problems they will give you the standard deviation, and you can calculate the probability by going into this and set the lower and upper value, your standard deviation and your average, and then calculate the probability for you to be within that. Say, by the way, we should do calculation here. What is the probability that our bread is more than 2 standard deviations away? So that will be like this, right? What is the probability that x is less than, now 2 standard deviations away, that is 20 grams away, right? So less than 480 grams, or x is larger than 520 grams. So what you can do here is calculate what is probability that you are in between these two, and then take 1 minus that. And we can see here that should be twice of this value if everything is right. So if we go in here, and why it should be twice of this is because if you are above or below equally far, and remember this curve is symmetric, so you should get the same value, 2.28%, that you are above 520 and the same percentage that you're below 480. But we can calculate the probability in between these. So write 480 to 520 and calculate that probability, and you can see that would be 0.954 approximately. Probably that you're in between. We have just calculate this, and this probability we want to calculate will be 1 minus this 0.9544. Actually 9545 will be very close, right? Okay, so let's calculate that. 1 minus 0.9545. And that will be this. We can see we divide that by 2. We should get basically this one back, right? So we can see that this probability here is 0.0455. Or if we want to, we can write it as 4.55%. And that would, in other words, be, draw this curve here, 480 and 520, and the area outside here will correspond to these 4.55 or 0.0455. So that was an introduction to normal distribution. Thank you.